All right. So similar agenda to the last couple of times. We'll just start out and, love to hear from folks on kind of what you have found interesting in this lesson. It seemed like the homework this last time was really to try to do as many of these data sets as you can. And potentially even submit them to Kaggle. I'm wondering what folks have done. And also like have you learned anything interesting about learning this stuff or found any interesting resources that would be good to share? There were a couple of questions that came up last time. I had asked one about in the learning. I don't think I used pre-train here, so it wouldn't show up. But in that, when you're doing the learn phase in a pre-trained learner, it showed those the three different progress bars, and Kai answered that one on the on Slack. Those were the train and validation and test set.
So the third one was the test pictures for Kaggle, right?
Right.
Yeah. Okay.
Right. Yeah, I think what threw me off was that you've got the two folders, but you're kind of calculating the validation set based on the indexes. Right. That's this thing here that we do, the validation indexes. You just kind of get some random set from your training data and then pass that in your get data thing.
I think Jeremy mentioned that it's by default 20%.
Mm-hmm.
So it's really just 20% of the data set as a holdout for validation.
Yeah.
Yeah.
Someone had asked last time about they were running into problems with loading or saving and loading models to disk. I haven't run into any problems with that. Has anyone else had an issue with that? No? So, at this point, I'll open it up. What did you find interesting in lesson 3? Anyone want to get us started?
Well, for me, I found it interesting about the training using different resolutions, 64, 128, 256. And I guess the guidance that if the things you're working with are sort of similar to ImageNet, that you don't want to, resize it because you're going to basically destroy the pre-trained information versus, for instance, when you're working with the planet data, in that case, you do want to do it because you're going to avoid overfitting and you're going to train faster. I thought that was kind of an interesting technique.
Mm-hmm.
So in general, one question I had was, in general, when these things are pre-trained, is it pre-trained always on ImageNet? So that's kind of how you decide?
I think you can pre-train on anything. ImageNet is a popular one, but you'll also see like pre-trained models on these CFAR data sets and some other ones. But the ImageNet, I think, are the only ones that have come up in this course so far. Has anyone come across other pre-trained models?
I think all the models in the course are pre-trained on ImageNet.
Yeah, but I think there exists pre-trained models on other data sets that you can find.
So basically, if the things you're working with are similar to what it's pre-trained with, you don't want to take the resolution really low, because then you'll end up basically taking the pre-trained network further away from where it was to start with. Whereas if it's very different, then you're just taking advantage of the early layers that have been pre-trained. Is that the idea?
Yes, I think so.
Yeah, related to that was the one of the questions that he got in the lecture was when someone asked if you could do your kind of unfreezing earlier, and he kind of talked about how you wouldn't want to do that because if your data set is similar to ImageNet, you've got this kind of great starting point. And you can train those last layers and take advantage of the earlier layers before kind of blowing it all away. I thought that was interesting as well.
Yeah, Jeremy showed those pictures again from those filters inside the network that are detecting shapes and textures and stuff like this. And that's all helpful for everyday objects. And while they're not helpful for finding things in satellite images.
Mm-hmm.
Hey, the other thing I found useful, interesting was this multi-dimensional kernels. You know, in the first convolution he has, the kernel is just a two-dimensional one. The second convolution, his conv v2, it's a three-dimensional kernel. But then he goes on to say multi-dimensional, but I don't think the dimension of the kernel goes beyond three. Three is the highest, right?
No, I don't think so. When you go deeper in the network, you have more filters, and then you have more channels or more dimensions.
Well, the more channels you have, it's just you may have 10 channels, so the third dimension value is 10, but it's still a three-dimensional.
Yes. The tensor is three dimensions, yes.
Yeah, so there's no fourth dimension, fifth dimension. No. Three is the maximum dimension.
The fourth dimension is batches in the tensor.
Yeah.
I got the impression, like he only in the Excel example, he only went 2 layers deep. So it didn't, it kind of spread to a tensor of 2. But I got the impression that like the deeper you went, kind of each of those, you'd have filters for basically each of the layers. And so the tensor dimension would continue to grow. Is that not the right way to think about it?
I think the tensor dimension stays the same. You only have more stuff in one dimension of the tensor. So when you have 10 filters, you have 10 channels, and the number changes to 10 in one in the third dimension. Yeah, and when you have the fourth dimension is the batches. So you stack the images over each other, and then you have one more dimension. That's the fourth. But I think you don't go beyond 4, at least for images. You can do video, and then you have the time. That's the next dimension. But I think for images, it's 4, including batches.
Well, I tend to agree that there's a fourth one with the batch size, but in terms of the kernel, the batch size does not apply to the kernel. So the kernel is still 3-dimensional, but with a batch being a third component, a fourth component. Yeah.
What else have folks found interesting in this lesson?
Convolutions and rectified linear units are no rocket science. I mean, it's pretty easy math.
Well, you know what? I tend to think that the convolution, the way Jan LeCun did it and the way he presents it here, it's overly complicated. You can think of it simpler, where, for instance, this first layer of convolution, you have an entire 2-dimensional grid of neurons, and that are sharing weights. Now, in biology, it's really only one neuron, and to get that neuron to see the full image, the eye in biology just moves around the image. So I think neural networks here overly complicates it.
But you don't have one neuron for each point in the grid. You really have so one kernel has just one neuron. you add up all those values from the grid, from the kernel. It's a weighted sum, and the weights are the weights for this neuron, and then you pass the resulting number through the rectified linear unit, and that's really just one neuron basically for each filter.
I agree. But
Yeah.
you know, I think Jan LeCun says there's a whole square full of neurons with shared shared weights, and it's not really shared weights.
Okay. Yeah.
Yeah.
Any other thoughts or interesting ideas? I thought I found the Excel thing. It's the first time I really looked at that. That was a really, I think, useful way to kind of visualize this. And I have all kinds of ideas of how to like do more with Excel that may be interesting. I don't know if I'll ever get a chance to play with that stuff, but it was kind of an interesting, you know, simple way to visualize all this stuff, I thought.
Yeah. Agree.
What data sets have folks worked on? So I know a bunch of folks had been working on the dog breeds, obviously dogs and cats, and the satellite stuff. Has anyone found any interesting other data sets via Kaggle?
I have a data set which I haven't had a chance to play with yet, but it's they have lending club data of basic attributes of people that have gone to get a loan and ones that were accepted and declined and so on. And I thought that might be interesting eventually to try to build a model which, you know, might help predict which might be good people to lend to.
Yeah, along that line, there's a new competition that just started, I think. This it's also lending related, this home credit default risk. Has anyone started looking at this one? I haven't gone into it in much detail and don't have a sense for the degree to which it'll lend itself to a deep learning type of an approach. Most of the folks that are submitting stuff so far are using like decision trees and stuff, pretty standard stuff.
I think for structured data, that's at the moment the way to go. I've seen in Kaggle competitions deep learning in ensembling models along with tree methods, but I think at the moment they are leading when it comes to structured data.
Yeah, I thought in the video towards the end of the video he was talking about I forget the competition, but it was some competition that was kind of structured data focused, but he seemed to suggest that this same approach worked pretty well for it.
Yeah.
I'm looking forward to that one. I've got the data. I don't know, my mic is really quiet. Can you hear me?
It is faint, but I can hear you.
I will speak up. I'm looking forward to that one because I think that what we're seeing is probably people with experience in this area are able to kind of cut through and don't need the deep learning. But feature engineering with the deep learning is where I guess the advantage would be because you can just create so many more features automatically. So I'm sure there's got to be a way. I'm looking forward to trying that one out.
Yeah, I think, you know, I downloaded the data also. I haven't opened it up and started looking at it. I think one thing that I noticed with that other data set that he was talking about was that there was a lot of data. I forget, I think he said something like 3 million rows or something like that. With this one, the files seem small, but they're not image data or anything like that. So that doesn't necessarily say anything yet. Yeah, but it'll be interesting to see what can be done there. Cool. Let me catch up on the chat here. someone was starting out, starting out with plant seedlings this week. Has anyone, that one's been mentioned in the videos, I think. Has anyone?
Yes, last time. Last week I did that.
Okay, that's right.
It worked pretty well. I got up to, I think, 96%. Yeah, 96%. And yeah, well, top 10 were 100%, but I think that's cheating. And so I was at least in the top third, I think.
Yeah, one of the things that that I found kind of interesting for dog breeds was like, if you know, without having the competition there, it's tough to get a sense for like just what's good and what's not good without you know, either some kind of background business context or you know, a leaderboard to refer to or something like that. And Jeremy makes the point in the videos, and I think we talked about this previously, like if you're doing just a kind of binary classification, you know, your expectations for what's good may be very different from if you've got a ton of classes.
Yeah. So that was 96%, I think, with 12 classes, and that's pretty good.
Yeah. Yeah. And then the dog breed, there's a ton of classes, and I think 93 something percent is the best I've seen, something along those lines. Grocery sales forecasting for structured data, Srinivas said. And the Rossman, is that what the Rossman was that was mentioned in the class? Was that grocery sales forecasting? That's right.
Yeah.
Yes. Yeah.
Yeah. And so that's like, when you started talking about that, I had the same thought, Kyle, like that's not usually what I associate deep learning with, but there was something about that seemed to lend itself to this approach. It may be the volume of data, it may be something else.
Yeah. I think I can't really explain that, but the feature engineering for this kind of structured data set is different from those in the image recognition with convolutional nets, because you really have to features like, for example, adding a few things up together and stuff like this are always good, and that's something that neural networks tend to not really cannot learn very good. It's works much better for finding features in images.
Mm-hmm.
So I think that's the reason why, at least on Kaggle, at least last time I checked, the tree methods and gradient boosted trees and stuff like this were leading in structured data.
Yeah, and I noticed, at least on the Rossman competition, there was a fair amount of that kind of feature engineering that even he walked through in the demonstration.
I mean, it's feature engineering that really takes into account that you have to think about. So, for example, people incorporate, Jeremy told that, people incorporate weather data because they know if the weather is bad, people don't go into the store. So
right.
That's something a neural net would not find.
Yeah.
Naturally.
Kazax mentions, where was that? Has anyone tried it on spectrograms of acoustic signals? Is there an acoustic signal data set on Kaggle?
Actually, I've not tried that, but I've seen that in the company I work for. They tried that for predictive maintenance tasks. So you can Fourier transform a audio signal, and then you basically see something like a picture of the spectrogram, and then you can apply convolutional networks on that.
Yeah, if anyone comes across any data sets on that would be really interesting to take a look at.
Yeah, I'm curious to see how convolution neural nets work on spectrograms. There's also spectrograms on brainwaves that I'd like to try.
Yeah, I've wanted to apply this stuff to actually the podcast that I do. Like, you know, occasionally there'd be like weird background noise, or if I'm in a kind of a conference hall, sometimes there are weird background noises that are difficult to get using traditional methods. And there are these plugins that you can get for your digital audio workstations that will show the spectrograms and manually allow you to remove the noise using them. But it'd be interesting to apply deep learning to that problem.
Well, I think for that task you have to work in the time domain, and that's a bit more complicated because it's just more data. I think so.
I would imagine you could sample, and I mean, even using that to create your data sets. If you have a clean sample that's, you know, 30 seconds long, you can kind of turn that into 30 different samples or n different samples using a sliding window, which maybe might make it easier to create training data.
Yeah.
So is someone going to jump in, chime in?
Oh,
Or is that
that is
background
fine.
noise?
Yeah, Sam, just one question. Can you maybe start a poll? Who of the attending people have some background in ML? That would be, I would be interested in that. So how many people are really just starting from scratch and did not do anything in ML before?
So I just tossed that in the channel, the Slack channel. So if everyone take a second to respond to this poll, what's your prior experience with machine learning? We talked a little bit about this the first time. I think some folks, there were quite a few folks that had done the Andrew course. Has anyone done that course?
I did the one on Coursera.
Coursera course?
Mm-hmm.
People are asking how to join the Slack channel. So you should have received an invitation to Slack, and to join the channel, if you are in Slack, then there's a channels, there's a sidebar, and you click on the plus, or you click on channels to browse the channels, and then just look for Fast_AI. So the number of folks that are replying with 0 prior experience is increasing.
So it's from 0 to 10?
Some folks taking, no, I left it open-ended, but someone created a 0 and has gotten quite a few co-signers on that one, or votes. I think folks wanted multiple choice. 4. What does 4 mean in this context? Is that year? Maybe I'll create some choices. Oops. Bye, guys. Adrian, so is anyone, actually, I'm not gonna try to wing these choices here. Kai, if you want to figure out what the choices should be for your question, I can add you to the.
I don't know. Maybe if people just write what they did, that's a little bit interesting. But and if they have 0 experience, they can click the 0. It's already there.
Yeah. Okay, so is anyone still having problems finding their way onto the Slack channel? Paul or Jennifer? Some folks who... Go ahead.
What is the URL again? I'm sorry. Is it fast_AI?
Fast_AI is the channel
workspace
name. But
what's the workspace?
TWiML AI. TWiML AI.
Gotcha. Thank you.
Slack.com. Oops, what the... There you go. And so some folks have, maybe joined the meetup some time ago, but did not accept the Slack invitation. If you just go to that twimlai.slack.com, if that is your situation, and you can, I think if you do a password reset, it'll, you could either search email for the invitation, or I think I was able to get someone past that by having them do a password reset. But if you need me to resend the invite, I can do that as well. Someone's got the background music going for us. All right. What do we have here? So no professional experience, but MOOCs and nano degrees, small amount of coursework, quite a few folks on that 0. Classic ML. Kai, in your case, what was classic ML?
So I used machine learning methods like tree methods and logistic regression and stuff like this for predicting reliability of components in drivetrains. Yes. So I'm not developing algorithms in machine learning, but I would say I'm a heavy user. Yeah, for those classic stuff, and also neural nets, but dense classic MLP networks.
Mm-hmm.
And some tinkering with ConvNets maybe, but just for fun.
Okay.
Before Fast.ai, I was using H2O, which was actually quite easy to use.
Yeah.
The only was getting the model out of that whole system. But when you embed it in R, you can do interesting stuff with it.
Yeah, I've seen some interesting looking demos of that. Awesome. So I'm curious if has anyone, going back to that third question, has anyone found any interesting kind of, things that have helped them, learn or understand this stuff better, or interesting resources? Kind of asking the meta question here about what folks have found useful. There have been a bunch of, I guess for me, one of the examples from this lesson was that Excel spreadsheet. And I think I shared some links to, well, various folks have shared links to blog posts last time.
Sam, where can I get up to speed? Sorry to just jump in. So this is all new for me, the whole format of this meetup. So what is the best way to catch up if I've missed the prior meeting?
Yep. So if you go to twimlai.com/meetup, you'll find the recordings for the previous session. So session 2, session 1, and session 0 was kind of a orientation.
Okay, thank you.
Absolutely. So I think some of the things I came across this time were, I think that was from the past one. I continue to find the Fast.ai wiki and lecture notes useful. This also might have been last time. Somebody shared this one?
Yeah, that was me.
Was that you, Kai?
Yeah.
This was another interesting one. Yes, convolutional neural nets do care about scale, and talked about the kind of resizing issues. Yeah, I don't think actually any of that was, I think most of that we talked about last time. Anyone have any questions or stumbling blocks or challenges that they've run into, or things that they don't fully understand yet that we can go over?
I'm sorry, but I'm still catching up. I am a good programmer, but I really don't have much experience in Python. And I know that Jeremy recommended a book, but is there a set of web pages or something that is even quicker to come up to speed in Python?
I think
someone recommends
the Python for data science book you mentioned is also available online for free, isn't it? Or did I get this wrong?
Yeah, that was Wes McKinney.
Yeah.
McKinney Python data analysis, I think. That is this one. But there's also for...
I think it's available on GitHub as a markdown style book.
This is a good book for general Python stuff, but I think like if you have a programming background, like I think if you go through like the first 4 chapters of this fairly quickly, like the big thing that is very Pythonic that comes up a lot is lists and like list generators and things like that. I don't think you need to necessarily go super deep on Python because if you have been following along with the lectures, like a lot of the stuff, you know, is fairly repetitive, and it's more related to these libraries than it is Python per se. But if you have a kind of I think a overview understanding of the basic syntax of Python and how lists works, then you'd probably be able to follow along just fine.
Great, thanks. The thing that I'm worried about, but I haven't gone to yet, is the data formatting or massaging that is involved. And so he shows how to do it on several things. Also in lecture 4, he goes into it quite a bit too. But I'm a little worried when it comes to my own work that I'll be stuck at that.
Yeah, I think that's where this book is probably, like a lot of that I think is going to happen in NumPy and Pandas, and I was definitely kind of cargo culting his notebook from, you know, on that. I was trying to take the satellite stuff and kind of get the satellite data ready to submit to Kaggle, and presumably the way I started was using the thing that he did for I think it was the dog cats or dog breeds, using Pandas, but I don't know Pandas particularly well, so it's a little bit of experimentation there, I think, for me as well.
Wes McKinney is the creator, right, of Pandas?
He is, yeah.
Okay, thanks.
Well, one course I did recently, which was really good, was the edX Machine Learning Columbia course, if you're talking machine learning in general.
Okay. Confession, I'm looking at archive of current competitions on Kaggle, feel completely overwhelmed, even looking at kernels, feel I need to learn quite a lot. Am I doing it wrong? Should I try more coding exercises before a Fast.ai MOOC? That's in it. And you just, if I remember correctly, you just kind of started working on this course. Is that right? I think my sense is that the approach that they take with this course, this top-down learning approach, you kind of have to get used to not fully understanding things. And like even in the first 3 lessons, you go through the first lesson, he talks about a bunch of stuff, like you get what you can out of that. Then you go through the second lesson, he talks about basically the same stuff in more detail. You understand it a little bit more. You go through the third lesson, he talks about basically the same stuff in more detail. And I think what's challenging about this kind of approach is that, you're really kind of on your own to find the things, figure out the things that you don't really understand or that you want to learn more about and, research them. But I was thinking just last night that, one approach to this course that might be useful is to actually just watch all of the videos and then start again back at the beginning and go into more detail, because some questions that I had from the first lesson were, he answered them in a lesson 2 or 3 videos. That's happened quite a bit so far. Not necessarily recommending that, and I don't know if they recommend that, but it's a possible approach. But anyone else have any thoughts on that comment? Kind of learning approaches with this MOOC. It's definitely designed for folks that have some coding experience, enough I think to understand the lessons, but I don't think we've seen any significant programming types of tasks. It's really just the programming is Python's a tool for doing the data manipulation so far.
Well, it sounds like, the pedagogy model that they've tried to suggest for this course is basically one where you get your hands in there and kind of get dirty, trying to play with things, even though you're not understanding it all, rather than kind of going through it all and then trying to understand it and then coming back. I think that that's sort of their intent. And they suggested that people got the most out of it by trying to do it that way.
Yeah, and they definitely do mention that they recommend that you plan to go through it a few times, and you'll get more out of it each time. In general, is it okay to invest 20 to 30 hours to start getting baseline results on recent competitions? What does that mean? Baseline results on recent competitions. I guess you're talking about Kaggle there. I would say kind of stick with the course. Again, if I'm remembering correctly and you're just starting, if you've got the 20 to 30 hours to put in to the first 3 lessons, you should be able to get baseline results, on those first 3 lessons just based on following the course. Manuel just muted you there. Your fan's blowing pretty forcefully or some background noise. Are your connections as bad as mine? We'll try to listen and see. For learning pandas, use past SciPy or PyCon conference tutorial on NumPy and pandas. They're good. Srinivas will send links soon. Srinivas, you can drop those into the Slack channel. Those would be useful, I think. And Matt is also agreeing with the hold on and get through it once approach to the course. Any other stumbling blocks generally, or questions relative to this particular lesson?
this is helpful. This is Matt. Just again with the idea of going down rabbit holes. I mean, at the end of the day, like this is the meeting point of a lot of very deep topics. So, like, I think this Fast.ai course is pretty amazing in that it gets you started, and then kind of wets your whistle for all these other pieces. But like we were talking about the data munging, like that's a huge that's data science, right? Like how to clean up incoming data, that's a really big deal, and that's its own rabbit hole. So I think, and all the statistics and certainly the deeper math. So I think this course is pretty amazing in that like it kind of gives you the overview and gives you like a working knowledge of it, so you can actually go and apply these things, and then and then go spend the rest of your life digging into statistics, because you can, and it'll be fun, but I think it's very reasonable to feel overwhelmed, because it is an incredibly it's a meeting point of a bunch of very rich topics. That's my 2 cents.
And also, I think you have to change your mind a little bit, because I mean, in school and at the university, it's really different how you learn things. And
yeah, right, absolutely. Yeah, I agree. You kind of you're trying to dig into these esoteric topics, but here we're just trying to like, hey, get a classifier that works, and then hey, tweak it, make it better.
Yeah. And for me, like even on the one hand, I can definitely, reflect on these first 3 lessons, and I have, a much better sense than I did coming in, like how to approach building out a classifier for, as Jeremy would say, a world-class classifier for image data. And I could, given a data set, I can pull that together and get, I would think decent results, but there's still a little bit of kind of magic incantation, from my perspective, in terms of like when he shows, how he organizes the different learning steps and like what he unfreezes and how he sets the learning rates. Like, I don't fully get it. It's like, I feel like I'm getting close. But I'm assuming that, as I have more time to play around and as we go further through the course, that stuff will all kind of sink in and gel. And each time I kind of play with a new data set, it gets more clear for me. So I think, again, for me, a lot of it is like, there's some degree of being a little bit uncomfortable with, knowing now all the stuff that you don't know.
And I think in this neural network models, it's more than in any other machine learning discipline, really kind of gut feeling how you choose some hyperparameters. So for example, this learning rate thing, that's really, that's really something that he just learned by experience. He saw on some data set that it works good, and so he concluded that, you have to set it like 10 times smaller than the actual learning rate and stuff like this. So that's really, that's gut feeling.
Yeah.
I also found it very, I don't have my camera. I don't know why. My camera.
We got you, David.
Oh, okay. Hi, everyone. I've actually ventured a little bit further into the course, and it actually gets harder. So my take on this is that what he's trying to do is to give us a taste and a starting point. I'm actually a full-time on this right now, and I'm working on my own data set as we speak. So so if you spend weeks and weeks and months trying to build a model, then I think what he's suggesting makes perfect sense, which is you can accelerate to a useful result with Fast.ai very quickly. Sorry, the crows are yelling. But, and then once you've accelerated to that point, you then have to essentially tweak the hyperparameters over and over and over to get what you want. And also you have to set up the curriculum. I don't know if any of you have encountered curriculum-based learning, but the idea is that you would start with, say, ImageNet, and then you would use the differential learning to apply a closer data set, and then a closer data set, and then a closer data set. The idea being that every time you get a bit closer, you're transferring the learning from the well-established sets to your specific needs. So it is very powerful. I actually found this part of the course much more tractable than that which is yet to come, which gets pretty intractable pretty quickly. But yeah, has anyone ventured further into the course beyond the image stuff, into the spreadsheets and into the more low-level approaches?
Starting from which lesson? 4, 5?
Yeah, 4, 5, 6.
Okay.
Yeah.
I'm watched 3.
Oh, okay.
Yeah, I'm at 3 as well.
Yeah,
okay,
I watched lesson 4. The structured data stuff is really interesting, and it's really practical in in industry, I think.
I agree, and but setting up your training set and trying to really engage in lessons 4, 5, and 6 is much more challenging than the first 3 steps. But that's just my 2 cents.
And do you find that are you doing the same general kinds of things, but for kind of, with slightly different takes, or is it, a whole new set of tools that you're learning for the structured data sets?
So it all revolves around a wonderful tool called Pandas and NumPy. So Pandas is really just Excel done in Python form. So let me see if I can get my video working here. Yeah, so Pandas is just a Python library. It's very well done. I actually watched some separate tutorials on Pandas, and Pandas is a powerful tool all by itself. It doesn't need you don't need anything else. And I think that's his point. What he's trying to do now in the later lectures, the sense I get is he's trying to demystify what is offered in Fast.ai even more, so that you feel much more comfortable peeling back the layers, looking under the hood and tweaking it for yourself. So he takes you right down to PyTorch, he takes you down to Excel, and he really gives you a visceral sense of what's going on at every level. And I think his goal is to empower us to not just float on top of Fast.ai and not delve any deeper. That he's trying to encourage us to go deeper and to essentially just demystify it all. I'm encouraged by it. I have made a number of attempts to do the exercises in 4, 5, and 6 with some success. Playing with Pandas has certainly been very useful. I would encourage everyone to give that a go. Creating your own exotic data sets or downloading them from, I posted a site which has some large data sets, is also interesting. That all works well. So, it does give you a new tool set. Mapping that onto something that has meaning to you, I think, gets harder unless you've got a specific objective in mind. This isn't kind of entertaining learning. This is hard slog to nowhere kind of stuff. So, yeah, that's my 2 cents. I mean, I really enjoyed it. I just, it's more nitty gritty, more low level. So you need to have a real purpose in mind before this. I think the next section would really have a lot of relevance. That's my 2 cents anyway.
Interesting. That's interesting to hear. One of the questions that I had noted was, has anyone dug into PyTorch? Because I was starting to get a sense that at least understanding the shape of PyTorch would be useful. I ran into a couple of, it was hard. It's been hard in lessons 1 through 3 to get a sense for where Fast.ai library ends and where PyTorch begins. But it sounds like we're going to dig into that in more detail, David.
Very much so, and I can give you I can give you some foretelling on that. So Jeremy's words are, he does everything he can in NumPy and in pandas. So and everything that you want to do will work in NumPy and pandas. Essentially, he uses PyTorch to accelerate things when needed. So what he's trying to get at is that PyTorch is so Pythonic, it's so Python-like, that you can just do whatever you need to do in Python, and then when you need to, you just lean into PyTorch to get what you need accelerated done, and then you come back to NumPy.
Okay.
Yeah.
Also, I think in the Fast.ai library, they are really just wrapping a lot of stuff from PyTorch and setting some parameters to fix values or some best practice values. And so that's, I've seen a lot of functions really just wrapped around basic PyTorch functions.
Yeah.
I'm not trying to discourage people, but I am just trying to say that the tone changes significantly after lecture 3. It's a very different trip.
Interesting.
Yeah. So, but I'm very happy to and willing to collaborate with as a team or online or whatever you want to do some work in that space, because I think it would be beneficial to us all.
Yeah.
Sorry guys, can I just ask a general question? So I haven't completed any of the lessons so far, but I have been using deep learning models, so TensorFlow, Keras, and feed-forward networks quite a lot, but not implementing them using those frameworks, implementing them from scratch using NumPy. So do you think I should complete those? Is there a lead up to lesson 4, or can I just jump into lesson 3 or 4? What do you think?
I'll offer that I think lessons 1, 2, and 3 everyone should do, because they really give you access to the best image classifier capabilities there are. And if you are a practitioner, like if you do this every day, or if you want to do this every day, I think that 4, 5, 6, and 7 are mandatory, because they are the nuts and bolts, the bread and butter of what data scientists do every day. Yeah. So I don't know if I've answered your question, but
For me, working with structured data and classic models is also, I do that every day. And I also would recommend to watch the lesson 1 to 3, because he's basically shown this Fast.ai library, which is pretty good to start off, and I would not miss that.
Okay, cool. Thank you.
Pete asks a question about PyTorch versus TensorFlow. For that one, I refer you to the conversation that started all of this, the interview I did with Rachel, which is, where is it?
A little bit.
There it is.
Yeah.
So TWiMLAI.com/talk/138, or I'll drop the link here. And she spends quite a bit of time on PyTorch versus TensorFlow, at least high level.
You know, I dug into PyTorch just a little bit for like 15 minutes because I couldn't get the thing to save correctly with pre-trained turned off. So I think, you know, when you come to saving the model and stuff, that's all done by PyTorch, I think.
Mm-hmm. And I was asking about that. You mentioned that last time. Did you ever resolve that? I haven't had any problems with the saving, although I did, maybe you did figure this out, but it blows up if you try to load a model with pre-compute off that you saved with pre-compute on, something like that.
Yeah, that's exactly the problem I had. I didn't mean pre-train. I meant pre-compute. You're right.
Yeah, yeah.
I haven't resolved it. Sometimes it works and sometimes it doesn't.
Oh, really?
Why?
Yeah, I ran into that error and then found a post on the Fast.ai forums that kind of explained that pre-compute issue. And if you know, if I'm consistent about, you know, matching the pre-compute, because I think once you know, whether pre-compute is on or off changes the shape of the data structure that's ultimately saved. And then if you have them matched or mismatched, I should say, it runs into some, you know, index problem or like some kind of problem loading the data structure because it's expecting a different shape.
Right. Yeah, I'd like to dig into that a little more, see what PyTorch actually does and how it stores these pre-computed expressions.
Yeah.
Guys, can I ask a question about the structured data in session 3, I think? I was really intrigued by that because I haven't really seen it in any other course. So is there, I mean, I didn't look ahead. Is there more to come about that? Or did you dig into structured data and neural nets with other exercises? Because yeah, I only know like the trees and everything, boosted trees and stuff, but that was quite intriguing. Did you work with structured data in this way before?
The rest of the course is on structured data as far as I
know. Oh, is it really? Okay. So I
Yeah.
got dropped before, so maybe that's what you already discussed. Yeah. Okay.
No, that's fine. No, it's very much about unstructured data.
Okay, cool.
Well, he calls it. Yeah, once we get into semantics here, but yes, it's all about tabular data. I'll say it that way.
Okay, awesome.
Yeah.
I love having this Fast.ai Oracle. This is great.
Yeah.
Fast.ai Oracle.
Oh, it's just
the course in advance.
The course, yeah. David's inside, yeah, exactly. yeah. Well, it sounds like lessons 4 through 7 will be really interesting.
I'm kind of psyched, actually.
Mark your calendars appropriately. Cool. Well, that is the end of our time. Pete, I see your comment that you wanted kind of more detail and discussion on PyTorch versus TensorFlow in the group. We can remember to bring that up next time. You know, we can have a chat about that. Amazing demo that was posted from Earl. So take a look at that. I'll send out the chat after we're done so everyone can get caught up on the links that were shared and stuff. And this recording will go up within a few days. And yeah, cool. Good luck everyone as we dive into lesson 4. And catch you all next week.
Bye now.
Thank you.
Bye.
Bye.
Bye-bye.
Thank you.
Everyone.